Previously, we have found the probability of the intersection of two events through the general addition rule. Maybe we can write it here below. If we remember our general addition rule is that the probability of the union of two events, let me use A and E, would be equal to the probability of A happening plus the probability of E happening minus the probability of, that should be A. There you go, the probability of A and E happening. And then through this formula, we would just transpose to find the formula for the probability of A and E. We can also do the same when we talk about conditional probability. Let's just clean this one up here. There you go. So we have here the definition of conditional probability, that the probability of A given E would be equal to the probability of A and E happening over the probability of E happening. By cross multiplication, we can then see that the probability of A and E happening would be the probability of A given E times the probability of E. Since this is multiplication, we can also write it as the probability of E happening multiplied by the probability of A given E. This is better because we know that event E, this event happened first. So since we already know that this event happened first, this will then affect the probability of A given that E has happened. So if we want to know the probability of the intersection of two events A and E happening, we first find the probability that E happened, then multiply to the probability that A happened given that E has already happened. Now we call this one our multiplication rule or our general multiplication rule. We call this general because later on we will have a very specific rule which also involves multiplication. Let's have an example of this general multiplication rule. So for example, a lot contains 12 items of which 4 are defective. 3 items are drawn at random from the lot, one after another. Find the probability that all 3 are not defective. So, if we want to find the probability that 3 are not defective, in the language of sets, that would just simply be the probability of the complement of having it defective at the first draw, then defective at the second draw, and defective at the third draw. So what's the probability that after all 3 draws, it will still not be defective? We know that if we draw 1 non-defective, it will already affect the count or the number of elements in the sample space of those who are not defective. That's why it is important that when we write the probability of A and E, we would rather write the first event happening first, the probability of this happening first, because this first probability affects the counting or the numbers that we use for the second probability, the probability of A given E. Let's see this here. The probability of not drawing a defective would be based on these numbers. So if we have all 12 items, let's write it here. If we have 12 items, 4 are defective, 8 are not defective. So therefore, the probability of drawing a non-defective item would be 8 over 12 at the first draw. Now, at the second draw, since we already drew one item, it will not be over 12. It will be over 11 already. And the probability of again drawing a non-defective item, this has already been reduced to 1. Not to 1, but reduced by 1. So we'll remove 1. This becomes 7. As you can see, this represents our probability of A given E. So this is the probability that we drew a non-defective item, provided we have already drawn it the first time. And we will see that effect again on our third rule, We already have 2 non-defective items out. So there will be 6 non-defective items left to be drawn. And overall, 2 were drawn out. So we have 10 items in general. By the multiplication rule, we multiply these probabilities. Therefore, we get 14 over 55. Or 25, around 25.45%. So there's more or less a close to 1 in 4 chances, or exactly 14 out of 55 chances, that when you draw 3 items from this lot, all of them will be non-defective. Now, another way of writing this one, if you would notice, would be we can use permutation. In this specific case here, we know that we want to find the probability of drawing 3 non-defective out of 8 in order. So that would be, so another way of writing would be that the permutation that you take 3 out of 8 in order, out of when you take 3 out of 12 in order. So the probability above by multiplication rule can also be expressed as a permutation with the probability of the permutation of 8 taken 3 divided by the probability of the permutation rather of 12 taken 3, which will give you the exact same result. Try number 2 and see if you'll be able to find the answer on your own. Alright, let's try this one. An urn contains 3 red and 3 white marbles. 3 marbles are drawn from the urn one after another. Find the probability that the first 2 are red and the third one is white. So here we're a bit more specific. Now take note that in both of these problems, we are assuming that the items drawn are not given back because it was not stated. So unless otherwise stated, if the item is drawn, we don't return it. So we want to find the probability. I'll use this color here for number 2. We want to find the probability that the first 2 marbles drawn is red and the third one is white. So following this one here, the probability that we draw a red for the first time, that will be 3 out of 6 because there's a total of 3. 3 out of 6. Then, the probability of drawing red again, since from 3 we now have 2, and from the total we just now have 5, so that will become 2 over 5. Then the white, the probability of getting a white after these 2 draws would be, since there are still 3 chances, we still have 3 over. Now we just have from 5 we just now have 4. By the multiplication rule, we multiply this and we get 3 out of 20, or a 15% chance that the first draw is red, the second is red, and the third is white. And that is the general multiplication rule of probability.